Welcome back. In this video, we are going to take a look at one of the most powerful features that Excel has to offer in terms of how it presents data, and that is conditional formatting. We have seen that one way to present data and insights in general is through charts, but sometimes we also need to look at the raw data values, that is the numbers or the text that are actually occurring in our tables. And as you can see, sometimes that is not very easy because all you have is a bunch of numbers and text. However, when we do some analysis, we extract some summary values or some statistics or some sort of metrics from the data. And conditional formatting is something that helps us highlight some interesting statistics out of all the analysis that we have done. It's fairly powerful and it has saved my life more than I'd like to admit. So let's get started. As usual, this is fairly small, so let's go to the View tab and let's increase the zoom value to 200% so that we can see the data a little better. And let's freeze the top row so that Excel understands that that is our row header. Essentially what that means is that no matter how much I scroll, I can still see the top header and it understands that this is the label for each given column. So let's take a look at how we can use conditional formatting to look at some insights or some summary statistics of this data at just a glance. Now, the single entry point into conditional formatting is through the Home tab under the conditional formatting button. And when you click on this, you'll see a bunch of drop downs. Let's take a look at the first one. We see that we have this thing called highlight cell rules, which means that these are a bunch of rules that will help us highlight certain cells within our selection. As you can see, our selection here is the column A, which is the sepal length column. So let's take a look. We see that we want to highlight cell rules which are, suppose, greater than a certain value. So when you click on that, you get this new formatting rule dialog. This essentially helps us create a new formatting rule. A formatting rule rather, is just basically a set of conditions that are applied on every single cell within whatever selection that we have made, and Excel makes a decision whether it has to highlight that particular cell in a certain way or not. So essentially, we are saying that only format cells that contain something which is a cell value of greater than something else. So let's say we have cell values going from 5.1, 4.9, 5, and well, mostly we see values that are between 5 and 4. So let's say that we want to highlight everything that's greater than 5. And we want to format it with light red fill with dark red text. Essentially, the background of the cell is going to be light red and the content or the text of the cell is going to be dark red. And let's just click on OK. So there it is. Whichever whichever cell has a value of more than 5 gets highlighted in a light red background with a dark red text. Now this itself was just random. We did not necessarily put too much thought into how we want to design this formatting rule, and we can see that the more we scroll, basically the formatting has been applied to the whole column. We didn't really put too much thought into this. This was just an illustration, an example. So let us clear this out and try something slightly more meaningful. So then again, to clear it out, since our original selection was the entire column, we recreate that selection by selecting the whole column. We click on conditional formatting and that again shows us the formatting menu, and here we have an option called clear rules. So then under that we have two other options, which is clear rules from the selected cells or clear rules from the entire sheet. Now it doesn't matter which one we click over here because we have made basically any selection rules that we have made are the ones on this particular selection. There are no selections outside of this. So we can simply click this and it takes away the formatting. But in general, do be careful with the clear rules because sometimes accidentally you might click on clear rules from the entire sheet, and that can actually throw away a lot of hard work that you have done while arranging formatting rules for the rest of your sheet. So this is how you can add a particular conditional formatting rule and clear it. Let's try to take a shot at trying to create formatting rules that are a little more mathematically analytically meaningful. Let's say that in this column, sepal length, we want to try and find the outliers. So one good way to find out outliers in any numerical variable, as we have covered in one of our previous videos, is to find the average and then find the standard deviation. Whichever value is more than 2 standard deviations above or more than 2 standard deviations below the average can count as an outlier. So let's try that. Let us say that we want to calculate the mean first, which is the average of the sepal length. So let's just say that average sepal length, and we already know the formula for that. So let's say equal to average, and as we have studied in one of our previous videos, we just give the selection range, which in this case would be the entire A column. So I can just click on the entire A column, and that gets translated into A is to A. Let's finish the parentheses and press enter. So that's it. That's basically in centimeters what is the average sepal length in my whole data sets, 5.83. And in order to detect the outliers, the one other metric that I'm going to need is the standard deviation as well. So let us say we have a standard deviation for the sepal length, and let that be also computed with a formula. We already have a formula for that, stdev.p. Remember that we have two functions here, stdev.p and stdev.s. The stdev.p corresponds to the population standard deviation, whereas the s corresponds to the sample standard deviation. We are more interested in the population standard deviation. Again, the range that we want to give is A is to A, and there it is. So we know that the standard deviation of sepal length in this data set is 0.82 centimeters. Now, in order to detect an outlier, what we need to do is find out which values are more than 2 standard deviations away from the average. That is, they are more than 2 standard deviations either above or below the average. So let's compute something like that. We say that average plus 2std is basically, I again press equal to so that Excel knows that I'm entering formula. It's essentially this value plus 2 times this value, and then I press enter. So basically I'm saying that whichever value for sepal length is more than 7.49 is an outlier to the upper side. Similarly, I can take a limit to the lower side as well. I can say average minus 2 times 2std is basically equal to, I again take the average, and this time I do minus 2 times this particular value. So there we are. So whatever is greater than this is an outlier, and whatever is less than this is also an outlier. Now that we have these values, which are basically the thresholds for the upper and lower limits, we can recalculate our conditional formatting. So let's click on the column again and add a conditional formatting rules for the first time to find out which are the upper outliers. And let's say that we want to find out again with the greater than rule, and here we say that color with the same color scheme that we had earlier, light red background text and dark red, that is light red cell color and dark red text, and in this case greater than, I just click this particular value and then I press OK, and there it is. So none of these values are obviously outliers, but as we scroll along we'll see that we have some values which are 7.6, 7.7 and so on, which are outliers. Now if we see that almost no outlier in sepal length can be found in the setosa or even the versicolor species of the iris flower. Most of the outliers to the upper side that we see are found in virginica. What this means is that if we find any value of sepal length which is more than 2 times the standard deviation away from the mean, that would mean that it's probably a virginica flower. So this is an example of how you can apply conditional formatting and quickly at a glance see values that allow us to infer some sort of a useful insight from our data set. The idea is that if we have something as simple as this, then we don't really even have to do something like machine learning or classification or anything like that. We know at a glance that high sepal lengths correspond more likely towards the Virginica species rather than the versicolor and the setosa species. Now that's for the upper limit of the outlier. What do we have for the lower limit of the outliers? Let's try that again. Again, I click on A. Again, I go to the conditional formatting menu and add another rule. This time I say that I want values which are less than a particular value. So let's click on that. We say that we want a cell value which is less than this particular value, which is H9, which is average minus 2 the standard deviation, but I want to color it with a different scheme. So let's say I want to have a green fill with dark green text. So basically the exact opposite of what we had earlier. We want to color the lower outliers in green rather than with red as we had earlier. Let's click on OK again, and you see that we have pretty much no outliers to the lower limit. Of course, all of this got scaled because it's interpreting that as 0, but we see that on the lower side, at least by this particular rule, we have no outliers. We only have upper outliers. Now we only have highlighted upper outliers. We did not find any lower outliers, but that also leaves a bunch of these values unhighlighted. So if I wanted to see what happens if I were to range the entire, if I were to highlight the entire range of values, let's see how to do that. So basically we know what to do when something is more than 2 standard deviations away from the mean. But let's say that we also want to find out what happens when a value is between the mean and the first standard deviation on either side. So for that, let's calculate what happens when we have the average plus the first standard deviation. That would just be the average plus this particular value, which is the standard deviation, and let's press enter. And also we need something which counts the same limit to the lower side, which is average minus the first standard deviation. So that would then be equal to the average value, which is this value, minus the standard sepal, the standard deviation of the sepal length, and that's it. What we want to do is find out what happens to values between them. So then we can add another conditional formatting rule. We say that we want to highlight cells which are this time between two values, not greater than, not less than, but between. So there it is. We say that we want to highlight cell values which are between this particular value on the lower side, which is 5.00 something. So let's just click on this particular thing, and the upper limit is this, which is average plus 1 standard deviation. And since we saw that we did not have any lower outliers, no outliers on the lower end of range, that particular value which we used, which was for green, that was left unused. So we can just use the same value again. So there it is, and we can compute that. So let's click on OK, and there it is. So these are basically values which fall between the mean and the first standard deviation. So now we know what to do when something is either greater than the second standard deviation, less than the second standard deviation from the mean, between the first and the second standard deviation. The one other range that has been left out is what happens when a value is between the first standard deviation and the second standard deviation. So essentially what happens to the values that are between 6 and 7, and basically between 6.66 and 7.49, and the values between 4.18 and 5.09. So let's add that as the third conditional formatting rule. That should, by the way, cover most of the values in this whole spectrum, because as you can see, the lower limit is 4.18. So whatever is greater than this should get covered. And let's again add that rule. Go to conditional formatting, highlight cell rules, say between. Well, for the upper limit, we would have something like we want a cell value that is between average minus the first standard deviation, which is, or rather average minus the second standard deviation, because we are moving from left to right. Let's add that, and average minus the first standard deviation, and let's click OK. This time let's pick a different color. Let's say yellow fill with dark yellow text. That's good enough. And let's click OK. And that covers some of the values. Of course, we still haven't taken into account what happens between the second standard deviations as well. So let's do that. Again, add another rule, highlight cell rules, and we say that we want a value that is between, this time on the upper side of things. Basically what that means is we want values that are between the first standard deviation away from the average and then the second standard deviation away from the average, and these also let's fill with yellow text. So let's click OK. Now that, you see, will cover almost every value in the range. So there we are. Now in order to see everything at a glance, let's go back to the view tab and zoom out. Let's do a 25% zoom so that we can, okay, that's too small, that's far too small. Let's go back to say 75% and we see this whole range. We see that most of the green values, which was basically between the means and the first standard deviation, you see that they are laid out throughout. The red values are all to the bottom and the yellow values are mostly in the Setosa range. So that basically allows us to see what our data distribution looks like with conditional formatting. Let's zoom back to 200% to do further analysis. One way to manage all the conditional formatting rules that we have applied, and note that these can quickly get out of hand. Basically, we have applied more than 2 or 3 rules on this one particular column. One way to simply check that is go back to the Home tab and click on Manage Rules under the Conditional Formatting menu. So what this gives me is a list of all the rules that I have applied on this particular column. It tells me that basically there are 2 rules which make me which I have specified should be colored in yellow. There are 2 rules which should be colored in green, and there is 1 rule which should be colored in red. So I can just delete either of them, or I can add rules, or I can remove rules. Basically you can just make a particular selection here and go to the Manage Rules tab within Conditional Formatting menu to see all the rules that are currently applied on that particular column. So this is something that is useful for rule management. There's nothing to do over here, so let's just cancel this for now and continue. So now that we know what to do with conditional formatting, how to add rules, how to manage rules, let's move over to another category of conditional rules, which are basically the top bottom rules, which we call the top bottom rules. The earlier ones that we used were simply called the highlight cell rules, which take care of basic logic like greater than, less than, equal to, and so on. Top bottom rules are rules that inherently do some mathematics for us. So basically they are going to find the top 10%, they are going to find the bottom 10%, they are going to find the above average and the below average, and so on. Now of course we are going to, let's say, apply it on a separate column. Let's, just in the interest of clarity, remove all the rules that we have applied to sepal length over here, just so that we can see the data better. In order to remove rules, we can just go to clear rules and say clear rules from selected cells. So let's do that, and then our cell is blank. Now let's apply the top bottom rules on the sepal width column. So let's highlight that row and then click on conditional formatting and say that I want some top bottom rules. Now I want to say highlight the top 10% of all the rows, the top 10% values in all the rows. So let's click on that thing and say that I want the top 10% to be colored in red. So let's click OK, and we see that some values already show up. Then let's add another rule which says that I want the bottom 10% to also be colored in red, because essentially, let's say we are just interested in looking at the outliers. So there it is. We have all of the lowest and all of the largest values covered in red. Then I can also add another thing which says that everything that above the average, I want it colored in green. And then I click on OK. Now you see that one of the things that happened is that some of the rows that were colored earlier in red are now colored in green. The reason that happens is because the earlier rule is now conflicting with this current rule, and this rule has overridden the previous rule. So essentially, the order in which we apply rules also matters. If you want to re-add that rule, it is going to have to go here, manage rules, and basically that above the top 10 and bottom 10% rule, we just want to order it in a certain way. So we can just click on change rule order. And so we say that we want the above average to be executed the last. And so then we click on OK and we see that some of our red values, which were actually top 10 or bottom 10%, have resumed their original color. Now we know what we have done with above average, although to make sure we can always check out manage rules and see what we have done. So yeah, we have covered above average in green and we have covered the top and bottom 10% in red. So let's cancel this and let's add another rule. We know what we have done with the above average value. Let's do something with the below average values as well. And say that I want to format all the values which are below the average, this time with yellow fill, for example, and let's click OK. And there it is. So those are all our values. Again, see at a glance we can see that Virginica has a lot of yellow values, which means that on an average, Virginica's sepal width is less than the average. So we can use simply this particular, statistical fact to determine whether something is, well, it also seems like versicolor also has the same rule. So we can see simply that whatever is below average is likely to be either versicolor or virginica. But if we go back to setosa, we see that a lot of values are mostly green and red. So they are in the either top few or definitely above average. So if the sepal width is too high, the flower is more likely to be setosa. And if the sepal width is too low, either below average or far too below average, which is in the bottom few, then we can say that it's likely to be a virginica or a versicolor. So this is again an example of how we can simply use conditional formatting to figure out some very basic, some very obvious insights from our data. So now that we know how to use the highlight cell rules and the top bottom rules, let's go over to the next most interesting type of conditional formatting, which is data bars. It's essentially a way of trying to fill cells with bars which almost look like bar charts depending on the value of the cell. Let's take a look at how this is important. You see that in this particular data set we have 4 continuous variables. Now, one way to summarize the overall amount of variability in a particular data set is to simply sum up the variance of all columns, of all numerical columns in that data set. So let us try and find the variance of these 4 columns. Let's just copy these column headers and paste them over here. And here I can simply add a label called variance, and I can say, as we have seen earlier, we have a function called var.p, which stands for population variance, and in this case for the sepal length I will just add a to a because that's my selection, and I just press enter, and that's it. 0.685 is the variance of sepal length, and I can just drag it to find the variances of all of the other columns. Now let's basically try and transpose this data. So essentially I want the sepal lengths, or basically the column names, not to appear in columns here but in rows. So in order to do that, I can simply say equal to transpose. Transpose is basically a function in Excel which, when it is given a particular range, it's going to flip the rows and the columns. So when I complete the parenthesis and I press enter, I get something like this. Variance becomes a column and the columns which I had here become the rows. So essentially transpose is converting columns into rows and rows into columns. Now that I have the variances for the 4 different columns, I can also have something called total variance, which I can simply say is the sum of these 4 values. And there it is. Oops, something went wrong with my formula. I can do sum, open a parenthesis, and then make the selection. Yeah, this time it fills. If I try to do a selection without opening a parenthesis, it just stops everything it is doing and starts making the selection, which makes the formula go wrong. So there it is. So that is the total variance I have. Let's drag this column limit slightly ahead so we can read properly. There it is. Now, one of the most important tasks in summary statistics is to figure out how much each column is contributing to the whole variance. And that can be expressed as percentages. So basically I can just divide this by this and therefore express that as a percentage. So let's try to see how much variance sepal length is contributing to the total variance of the data set? Well, I can simply do that by dividing this value by this value and say that the contribution of sepal length to the total variance is simply the variance of sepal length divided by the total variance, which is that. And then I just press enter. And then I can just scroll down this value all the way over here, and that essentially, well, it should have extended that my formula, but it did not. Now let's take a look at why I'm getting this divide by zero error. If I click on this particular cell, I see that the formula is G18 by G22. Now G18 is this and G22 is this particular value, total variance, so the variance of sepal length divided by the total variance. Now if I click on this particular thing, you see it's G19 by G23. Not only while you're dragging, it's basically changed the row number, it's actually also changed this number to 23. So instead of making it change from G22 to G23, I want to keep G22 fixed because that's my value over here. So I can rewrite this formula as follows. I can basically say that it's this value divided by G$22. What this means is that this number 22 is now going to stay fixed. It's not going to change. And I enter that, and then again when I drag it this time, that gives me the right values. Obviously, the total variance divided by itself is going to be 1, and these are all the values I have. Now, of course, the idea is to express these as percentages. I want to figure out what percent of the total variance is contributed by sepal length, what percent is contributed by sepal width, what by petal length, and what by petal width. So in order to format a range of values or any selection as percentages, you can just make that selection and in the home tab click on this percent sign. So that basically formats my entire thing as percentages. Now obviously these are percentages and I can quickly see that 68 is very high, there is 30, there is 15, and there is a very small value of 4. But if I wanted to see the whole thing at a glance, I could just select the ranges, I could go to conditional formatting, data bars, and I can just pick one of the two, gradient fill or solid fill, and click on one particular bar. Let's pick blue bars, light blue data bar, and there it is. So basically that's giving me a small tiny bar chart which is embedded in my cells instead of creating a new one, which at a glance tells me that this particular value is very high. Of course, if I were to take the trouble of reading those values, it would have been very obvious to me what a high value is and what a low value is. But you see that this is a kind of presentation that quickly catches somebody's eye. And just by looking at it, I can tell you that petal length actually has a lot of variance. And now I can see it. See, out of the 4.54, 3.07 is covered just by petal length. All of the others are very small. So this is how we can use data bars to essentially present percentages and proportions in a very easy to understand manner. Of course, that's not the only way. We can also have something like a gradient fill. So essentially a gradient fill is basically something that has a color gradient. It goes from very opaque to a little transparent, and that itself depends on the value. It's the rate at which the opaque part changes to the transparent part, the length and the rate of the change of transparency, it depends on the value itself. So these are essentially conveying the same information, but you might want to pick a particular color or whether you want it a solid or a transparent range depending on the overall theme of your spreadsheet or whatever your aesthetic sense asks you to do. Now the next set of conditional formatting tools are called color scales. And in order to understand that, let's revisit some of the formatting that we have done on one of our existing columns. In the case of sepal length and sepal width, what we did initially in this video is that we created some handmade rules. That is, we said that values that are beyond a certain threshold, we want them colored in green. Values that are above or below a certain threshold, we want them to get colored in red, and intermediate values in yellow. Now, color scales are essentially simply an automatic way of doing that. They are simply going to take the whole range of values in a given selection and divide them across the different shades of a particular color scale. To understand that, let's try it out with petal length. So I make the selection, I go to conditional formatting, and then I go to the color scales menu and I select the first one, which is basically the green, yellow, red color scale. What this means is that lower values will be colored in green, middle values in yellow, and high values in red. So let's just click on that. And that's how it is. Well, it turns out I was wrong. I basically flipped the order around. The low values are going to be colored in red, the middle values in green, and the higher ones in yellow. And you see, again, at a glance, we can see the behavior of petal length as it traverses across the different species. We can see that Setosa values for petal length are mostly low, versicolor are somewhere in medium, and Virginica has really high petal lengths. To see this in a more concise way, let's go back to the View tab and try to zoom out to say 75%, and there we see it slightly better. The whole range as we go from top to bottom goes from red to yellow and orange and then finally to green. Let's go back to the zoom, the original zoom, and there it is. Now, to understand how color scales work in a slightly more detailed fashion, let's try a simple exercise. Let's say that I again want my columns and I want to perform some sort of statistics on them again. So I create simply the mean, which is, let's just call it mean, and I want to find out all the stratifications above and below the mean. So I have mean plus 1 STD, I have mean plus 2 STD, I have mean minus 1 STD, and I have mean minus 2 STD. So let's see what values we can fill in. Essentially the mean is just, do we have the average somewhere? Well, we have it here, but let's compute it again. Let's say that the mean is simply the average of A to A, and then I simply drag this out, and now we also need the standard deviation. Let's calculate the standard deviation over here and say the standard deviation is A to A, and oops, got the formula wrong again, and we can say stdev dot p. So that's A to A, and that completes my formula. I have my standard deviation for the sepal length, then I drag it across, I get it for everything. And for the mean plus one standard deviation, I basically can enter the formula and say equal to this particular value plus this particular value, and that's it. Then I can again drag it across, and there it is. I have the mean plus the first standard deviation limit for all the different types of continuous variables. Here I can again add another formula and I say that I want the mean plus 2 times the standard deviation. And there it is, and let me also drag that across, and that gives me the whole values. And I just do the opposite on the other hand, which is basically take the mean and this time subtract 1 times the standard deviation, and then I drag it all across. Here I do the same thing but 2 times the standard deviation, so I take the mean and I do minus 2 times this particular value, and that's it, and then I drag this across as well. Oh, well, here's our first surprise. We see that the lower limit is going into a negative value here. So basically petal width can't go below 0, but it seems like in order to find the lower outlier, at least according to the normal distribution, you need to go well into the negative value, which can't happen. Now here's what happens when we do a color scale on this particular table of values. Let's go back to the Home tab and then click on Conditional Formatting, Color Scales, and pick the red, yellow, green color scale again. When we click on that, this is what we get. We see that the lowest value is red and the highest value is green. Now, what can we infer from this? Well, let's take a look. If you look at the values in the sepal length column, you see that the lowest value, which is mean minus 2 standard deviation, is a little bit in the green, which means that it's somewhere on the green, yellow, slightly somewhere on the mid side or the middle portion of the entire range of values, and the highest value is green, which means that simple lengths occupy mostly the higher spectrum of the upper half spectrum of values. Whereas in simple width, we see that values go from somewhere in the mid range all the way to some sort of a lower range. Petal length, on the other hand, is a little strange. You see that we have values which contains all shades of colors. It goes from slightly dark red to yellow to orange to greenish yellow to red to orange to yellow to greenish yellow to dark green. This what this represents is that there is a lot of variation in these values, because in the same column you're seeing all shades of the color scale that you have chosen, and that actually corresponds to this particular value over here. When we say that 68% variance is found in petal length, what that means is that these values are, they vary a lot. There is a lot of variance in the sense that values range all the way from zero point 0.02 zero point 0.2 to 7.25. That's basically a large range for a particular variable to cover. And that fact we can also see directly from this particular color scale. Essentially, we're seeing colors that range all the way from green to all the way down to red. And similarly, in petal width, we see that the variation is not so large. It goes mostly from red to orange, which means that it occupies again the lower bottom rung of the spectrum. So you see that petal width, since it has mostly no green values, it has a low variance, and we know that it's basically 13% only. Petal length occupies most of the values that are already present in the color spectrum of your color scale, and that's why it has a high variance. This also has a very low variance, because you see most of the values are concentrated around orange, yellow, what do you want to call this color, which is a very small value of 4%. And this also has a slightly high variance, because we see values going all the way from 4 to 7, which is reflected by the color scale again, and that contributes to a variance of 15%. So essentially what we saw through bars over here, we can also see through colors over here. So depending on what sort of presentation you want to make, you can choose the right kind of conditional formatting and see it. One word of caution about how to pick color scales though. Whenever you want to make a selection to draw color scales, be careful about what selection you're doing. So basically, let's say that we want to not drag this whole thing, but we want to add a color scale only to this particular value, only to this particular column, which is just the sepal length. And here again, when I click on color scale and click here, we see that I get those values. And then again, if I do this other column independently of the first one, I pick the same color scale, add it. Here again, I pick the same color scale and add it. And here again, I pick the same color scale and add it. Do you see what the problem is? Well, the problem is that across all of these, the color scales are not changing at all. It's like they are basically occupying the same range over here as the same range over here. Or rather, at the bottom row, we see the same shade of red. We see the same shade of orange, the same shade of yellow, the same shade of green and dark green. Why this happens is because whenever you select a color scale and then perform conditional formatting with any particular color scale, the range of that color scale essentially adapts to the values that have been selected. They don't adapt to the values around it. So essentially, if you want to compress a bunch of values in the same color scale, you have to make the whole selection work. So here, this sort of a color scale is more valid, because we want comparisons of this value with this value with this value and with this value. We don't want comparisons of a particular value with only values in its own column. So that is why be careful when making a selection for any conditional formatting rule. So broadly, this is how you use conditional formatting to create highlights in your data, in your numbers. Well, one quick other way of presenting your work is to show charts. But at the same time, if you want people to look at numbers, which sometimes cannot be avoided, and you want to draw their attention to certain sets of numbers first before others, then conditional formatting is one way you can do it. And of course, make sure that the inference that is being drawn from this conditional formatting is obvious to people. So that's it about conditional formatting, and I will see you in the next video. Thank you very much.